Let's now solve problem number 4. A 30-foot tree casts a 10-foot shadow. If an eggplant casts a 5-inch shadow, how tall is the eggplant? After a few minutes, the shadow of the tree increased by 20%. How long is the shadow of the eggplant by then? Okay. So let's draw for illustration. This is your tree, and this is your eggplant. This is 30 feet, and if we draw the shadow, is 10 feet. Okay? Now this is your eggplant, and the height of the eggplant is unknown. Let's call it X. And the shadow is 5 inches. Okay, let X be the height of the eggplant. Now, we can actually compute this by simple ratio and proportion, because the sun is fixed here. The ratio between the height of the tree and the shadow is the same as the ratio of the height of the eggplant and its shadow. How do we do that now? Regardless, or the units of measure in this case are not really that relevant, because what are given are the relationships in terms of ratio and proportion. So now we have 30 divided by 10. 30 is to 10 as X is to 5. Okay? So in ratio and proportion, you don't say 30 over 10. You just say 30 is to 10 as X is to 5. Those are the ratio and proportion relationships. So, if you want to solve now for X, you have to simplify this so that you don't have a fraction. And you move this to the other side in order that you could have X only remaining. So, if you move this to the other side, this is denominator, this becomes numerator here. For the explanation on how that is done or how that happens, please refer to problem number 1. I have explained it in much detail. So 30 times 5 over 10. So that is 150 over 10. Therefore, X is 15 inches. Okay. Let's check that just to be sure. 30 times 5 divided by 10. 15 inches. So now you have the height here, 15 inches. The next part of the problem, so you have two parts of the problem. The next part of the problem is after a few minutes, the shadow of the tree has increased by 20%. How do you compute for an increase in 20%? So, after a few minutes, the shadow of the tree equals 10 feet plus 20%. Okay? How do you do that? There are two ways of doing that. You have equals 10 plus 20%. 20%, by the way, in decimal is 0.2. 0.2 times 10 equals 10 plus 2. Then you have now 12 feet. Another way of doing that, the faster way, is when you say you increase this by 20%, is actually, you can also, another way is 10 times 1.2. Okay? This one referring to the percentage increase. This is 20%. So if you increase it, for example, by 30%, you multiply it by 1.3. If you increase by 50%, you multiply by 1.5. So this is the shortcut. So 10 times 1.2 equals 12 feet. Now, the next part of the question, of course, is how long is the shadow of the eggplant by then? Now, we have to draw again here, similarly, but let's just draw the triangle. This is the tree. This is 30 feet. But after a few minutes, the shadow is now 12 feet. So, we have now computed the height of the eggplant as 15. Let's denote this new length of the as y. Okay? So by ratio and proportion, 30 over 12 equals 15 over y. Y now equals, move this y there, and then move it to the other side. So y becomes here. Wait. Let me just make it clearer. If we want to solve for y, then you have to move it to the other side. Okay? 30 becomes over 12 equals 15. You want the y to remain here as by itself. This becomes numerator here. This becomes denominator here. Therefore, you cannot see it anymore. So I'll erase this here and continue. Anyway, you can, as you view the video, you can actually go back to this. So from here, you have 30y over 12 equals 15. If you want the y to remain here, this becomes numerator, 15 times 12. This becomes denominator. So 15 times 12 divided by 30. The answer now is 6 inches. So that's the answer. From 5 inches, the shadow of the eggplant now has become 6 inches. So that's it. That's the solution to our problem number 4. And before I close, let me remind you, please click the subscribe button so that you will be able to watch each and every new video that I will upload.